Which substances can be transferred via a special type of transport involving the vesicle formation? What are the terms exocytosis and endocytosis all about? Let's start the spinning of the multicolored threads of this tangled and knotty wool yarn. Welcome all to Is Pharmacology Difficult Podcast. I'm your host, Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. When the drug substances or molecules which are unable to penetrate the biological membranes, they gain entry into the cell by getting placed in small, minute vesicles formed from the membrane enclosure. With the aid of membrane-bound proteins, then this process is coined the term of endocytosis. Are you getting the definition? That's the basic, that's the first and foremost definition and the simplest one that can be framed for endocytosis. It's very simple. In general terms, the substances they are unable to penetrate, but they do it via the vesicle formation. Now let's further know the two types of endocytosis. First, Pinocytosis. Now, pino in Greek it refers to drink, and cytos is meaning an empty vessel, and osis means procedure. And when you combine the three, Pinocytosis, it means the drinking procedure in an empty vessel. Wow, let's make a definition out of it. Pinocytosis means fluid uptake. The substance or the drug, it is engulfed in the solution. And broadly, to describe the process, let's imagine the process. That's the basic idea. First and foremost, minute cavities, they are formed by the invaginations of the surface membrane. Into these cavities, large-sized molecules, they get enclosed. That is the first step. Second step, membrane patches around the molecule. It covers it. It completely surrounds it and forms a sort of a covering. And this whole thing, it takes the shape of a vesicle. Are you imagining the whole thing? Just close your eyes and listen carefully and the picture will take shape itself. Third step, pinching of the vesicle and separation from the membrane occurs. And finally, it enters the cell across the membrane. The vesicle is pinched, separated from the membrane. It takes its own entity, individuality, and then it enters across the membrane into the cell. Isn't that beautiful process? Now the golden question comes. What drugs are undergoing this whole process? That is the golden question that we need to know the answer. The first example, and very good and classical example, is of insulin polypeptide, which adopts this process to go through the blood-brain barrier, and it's in fact enclosed into the liposomes. Low-density lipoproteins. And low-density lipoproteins, they are abbreviated as capital LDLs. Their absorption is another example of pinocytosis. Now, this whole process is occurring at the level of the lungs, and to be very specific, at the level of the alveoli. Now, the alveoli, they are infinite in number. So, the number of vesicles formed in the lungs, they are also infinite. Just, we cannot imagine how many of them are formed. So, it's a very massive process. Got it? Now, other types of endocytotic procedure, that is phagocytosis. Now, phagocytosis, pinocytosis, there is a difference. I'll tell you, but please, the basic idea, the basic concept and procedure is same. Everything is same. In place of the solution particle, there is no solution, there is a particulate matter. You know why? Because phago in Greek means to eat. And cytos means an empty vessel, and osis means a procedure. So it's the eating procedure into an empty vessel. Transport of vitamins like vitamin B12 after they bind to the intrinsic factor, that is a classical example of phagocytosis. Then some rare substances are also transported via this procedure of phagocytosis. They include the poisons, botulinum toxin, some allergic reactions due to antigens. They are all adopting this phagocytotic procedure. Now, what you have to keep in mind is the process, it doesn't value the combination with the carrier. Yes, that is a very, very, very important point. There is no carrier. Got it? Just mark it, remember it. Endocytosis involves no carrier. I've repeated it thrice. Now you should learn it by heart. Got it? But there is use of energy. Okay, it's nothing complicated. No carrier, but use of energy is there. Now let's turn the talk tides towards exocytosis. Till now we were talking about the endocytosis. It was of two types, pino and phagocytosis. Now we are turning the tide of the talk towards exocytosis. Now when the substances or drugs etc. they are released via the opening of the membrane-bound vesicles to the outer side, that is known as exocytosis. Exo means towards the outer side. So the particulate or the solution matter, it is released from the vesicles towards the outer side, and this process is known as exocytosis. Now, what all things adopt this process? Let's get to know that. Many hormones and transmitters, they are released via this mechanism. And the classical one is noradrenaline. Now, I will discuss around the autonomic nervous system about the uptake, the release, and the whole process of the formation of noradrenaline. Not now, okay? Now, one good supporting point here is the secretory cells or the nerve endings. They foster, they cultivate, they support the fusion of the vesicles to the membrane once they are activated. And then the contents, they are released into the space outside. So there is a use of energy, but mind it, there is some supporting mechanism. And what are this? The secretory cells, the nerve endings, they are activated and then they foster the release of the contents from the vesicle to the outer side, outer space. Now, before I pull the curtains down for today's talk, a little head-to-head about the filtration really deserves a heartful talk. Yes, it does. Now, what is filtration? Let's quickly get through all this. It is not very long topic. It's a very small head and doesn't need a special episode for itself. It can be easily discussed under this episode. So, filtration, just get the basic idea. 2 plus 2 is what? 4. Okay, that was not a mathematical question answer round. I was just checking how much attentive and how much presence of mind you all are having. So, filtration is as simple as 2 plus 2. Yes. Nothing too much. It cannot be 5. Nothing less. It cannot be 3. It is exactly 4. Addition in mathematics. Okay? That's a good simile. A physical process where the free drugs or their metabolites having small structure, they are very light in weight, and they manage to move across the voids between the cells. Voids, no spaces. Okay, so that is so simple. It's just a simple process. The free drugs or the metabolites, very small in structure, very small in weight. They're just moving across these spaces or voids between the cells. Now, what drug or substances make use of this simple process? Well, urea, alcohol, glucose are very classical examples as they pass through the renal vascular meshwork. What process are they going through? Filtration. Have you heard about glomerular filtration? Now you got on the right spot. Yes, you're getting at the right place, and that's a classical example of filtration. Now, as I pass on this set of examples to embellish my descriptions, I also switch to the endings of today's vocal proceedings. Yes, I've said for the day, it's over for today, and now the hour of the day is to think, to ponder, to revise, and to let go of the day's dilemma. Well, I'll give you a golden rule to revise. Whenever you are revising, just chill and don't let anything enter your minds. No thoughts, no other stress, nothing. Because the achievement of revising and learning can only be attained into the empty minds. For all the updates and latest episodes of my podcast, please visit www.ispharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about the medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name, Is Pharmacology Difficult. If you are listening for the first time, well, are you? So do follow me here on whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.